Hello viewers, we have another question on trigonometric identities. The question reads, use the addition formulae for the sine and cosine to show that cotA minus B equals to 1 plus cotA cotB divided by cotB minus cotA. Deduce that if cotA equals to 1/2, cotB equals to 2, and cotC equals 3, then cotA minus B minus C equals to 3. Alright, so we have been given in the question that we should use the addition formulae for the sine and cosine to prove the identity. Alright, now, so the first thing we need to do is, okay, because we know that the left hand side is cotA minus B and the right hand side is everything we have here. Okay, so we need to understand that to prove one side to be equals to the other side, okay, to prove one side to be equals to the other side, we know that we are given cotA. We want to prove why cotA minus B, okay, is equals to 1 plus, let me just write that here, to prove that cotA minus B equals to 1 plus cotA cotB all over cotB minus cotA. Okay, so we know that the left hand side is equivalent to the what? Right hand side. We need to first establish that the left hand side is equivalent to the what? Right hand side. Now, because we want to use the left hand side to what? To obtain the right hand side. So we know that the left hand side we have cotA minus B. Okay, now since we are asked to use the addition formula for sine and cosine, so which means we can now what? Recall the addition formula, the addition formulae for sine and cosine, okay, for sine and cosine. So we know that sine of a difference of two angles, A and B, that will be sine A cos B minus sine B cos A. Then cosine of a difference between two angles A and B, that will be cos A cos B plus sine A sine B. Okay, so now we can express cot of a difference between A and B in terms of sine of a difference between A and B and the cosine of a difference between A and B. So we can say that cot A minus B is now equals to cos A minus B over sine A minus B. That's it. Now we can substitute the identity for sine A minus B and cos A minus B, into this expression. So that will be the next step. All right, substitute the identities for sine A minus B and cos A minus B into the expression above. So we know that sine A minus B, okay, no, we have cos A minus B over sine A minus B. That will be cos A cos B plus sine A sine B over sine A cos B minus sine B cos A. That's it. Okay, so now when we look at what we have in this expression, the new expression, and then compare it with what it was in the right hand side in what we are asked to prove, we have cot A cot B, and this is 1. So the only way we can get cot A cot B is when we look at the numerator, we can see that we are having cos A, cos B. Our next step will be to divide the numerator, to divide the numerator and denominator by sine A, sine B. So we can say cos A, cos B over sine A, sine B plus sine A, sine B over sine A, sine B, all over sine A cos B over sine A, sine B minus sine B cos A over sine A, sine B. So in this case, this will cancel out, so we have 1 in this case. So cos A over sine A, let's recall, we know that cot A will be sine A, that will be cos A over what? Sine A. Then cot B, that will be cos B over sine B, okay, over sine B. That's cot B. Okay, so which means cos A over sine A in this case will be cot A. Cos B over sine B will be cot B, plus this will be 1 all over. Then also sine A will cancel out. Then we have cos B over sine B. So we can see cos B over sine B is what? Cot B minus, then also here we have sine B will cancel out. We have cos A over sine A, which will be cot A. Cos A over sine A is what? Cot A. And this is the right hand side. So we can say that, therefore, the left hand side is equivalent to the what? Right hand side. You know, the left hand side is cot A minus B equals to 1 plus cot A cot B over cot B minus cot A. Proven. So we just prove that the left hand side is equals to the what? Right hand side. Now, also we are asked to deduce that if cot A equals to 1/2, cot B equals to 2, and cot C equals to 3, then what now? We want to prove why cot A minus B minus C equals to 3. Now, first, we need to understand that. Now, okay, in this case, we are giving cot A is 1/2, cot B, that's 2, and cot C equals to 3. We know that cot A minus B is 1 plus cot A multiplied by cot B over cot B minus what? Cot A, which is the one we just proved. Okay, the identity we just proved. Now, we have here that cot A is 1/2. So which means cot A minus B will be equals to 1 plus, what is cot A? 1/2 multiplied by cot B, which is what? 2, all over cot B again, that's 2, minus 1/2, which is cot A. So this will cancel this. So we left with, so which means cot A minus B will be equals to 1 plus 1 over 1/2. So this will be equals to 2. This is 3 over 2. Okay, so cot A minus B can now be 4 over 3. That's cot A minus B. Now, we know that cot A minus B minus C is the same as cot A minus B, okay, cot A minus B, then minus C, like this, parentheses, I use a square bracket, parentheses A minus B, is the same thing, okay? So which means which means we can then write cot A minus B minus C, okay, is equivalent to cot parenthesis a minus b, then minus c, close parenthesis. So we are now going to we're going to what? So we're going to treat a minus b as a, just like what we have in this one we prove, okay? And then we treat b as what? That's c as b. So which means if I want to write the identity for this, cot a minus b minus c, that will be 1 plus cot a minus b multiplied by cot c over cot c minus cot a minus b. Okay, so I just use this one to what? I write this in terms of this. All right, so which means cot a minus b minus c will now be equals to 1 plus cot a minus b. Now cot a minus b is 4 over 3 multiplied by, now what is cot c? Cot c is 3 all over, now what is cot c? Remember we have cot c. Cot c is 3 minus cot a minus b. Cot a minus b is 4 over 3. So this will cancel this, then we'll be left with, so we can say cot a minus b minus c, that will be 1 plus 4 over 3 times 3, that will be 9. So we have 9 minus 4 over 3. This is 5 over, 9 minus 4 is what? 5 over 3. So that this will be, so from here we have 5 multiplied by 3 over 5. This will cancel this. So we can say therefore cot a minus b minus c is equals to 3. And we just prove that cot a minus b minus c is equals to 3. The noblest pleasure is the joy of understanding. Bye-bye.